Hello and good morning, third period honors chemistry. Today is a really beautiful day, so I decided to write out my answers and work to my questions in sidewalk chalk. Alright, so question 1, we are asked to prove why a 0.1 molarity solution of barium hydroxide, why that pH is 13.3 and not 13. Well, if you get 13, your error is because you didn't make or improperly applied this barium hydroxide dissociation equation. So as we know, barium is located in group 2 of the periodic table, meaning that it is a positive 2 charge. Hydroxide has a negative 1 charge. So you move the barium's charge to the OH, which means that you have 2 OH atoms on this side. So that would yield barium plus hydroxide, but in order to balance the equation, we have to put a coefficient of 2 in front of hydroxide, because we need to have equal amounts of oxygen and hydrogen on both sides. So we are given that it was 0.1 molarity of that solution, but in order to actually find the hydroxide concentration, we need to multiply by 2, because there are 2 moles in our equation. So 1 times 10 to the negative 1 molarity, also known as 0.1, is multiplied by 2, which gets 2 times 10 to the negative 1 molarity, which is also known as 0.2. So we can plug that into our equation to solve for the hydrogen ion. Sorry about that. And we know that those two multiplied equal 1 times 10 to the negative 14 molarity. And we can sub in our OH concentration from over here into the equation. And then we can solve and find the hydrogen ion concentration is equal to 5 times 10 to the negative 14 molarity. Now, we can plug that in to solve for our pH using this equation. pH equals the negative log of the concentration of the hydrogen ion. So, using the number that we just got, 5 times 10 to the negative 14, we take the negative log of that, and we can find that it's 13.3. So, let's explore what would happen if you did it the other way. That meaning, in other words, not multiplying by 2. So you would plug in 0.1 here, which would get you a hydrogen concentration of 10 to the negative 13, or 1 times 10 to the negative 13, to be more precise. Taking the negative log of that, and you would get 13. So the problem arises because you did not write out the equation, or you didn't understand the equation, or you didn't balance the equation, and you just assumed that everything was 1. But you have to write out the equation. This problem illustrates the importance of that. Right, I will see you in my next video, question number 2, a little bit down the driveway.